Experimental aircraft X-29, with its forward-swept wings, appeared almost as if it should be flying backward. The unusual configuration sought to test new canard control surfaces and advanced materials to improve maneuverability response at a high angle of attack. It was flown together by NASA and the Air Force as a testbed for joint interests. While promising and positively reviewed by test pilots, the aircraft's new technologies made it one of the most aerodynamically unstable planes in the history of aviation. An incredibly complex system was needed to continually calibrate the controls to keep the X-29 in the air. Still, the promise of the potential new technologies was so enticing that even the Russians couldn't help themselves from trying to replicate them. Grumman's X-29 pushed cutting-edge aircraft technology to its limits back in the 1980s. But what does the future hold for aviation today? Check out this documentary from Magellan TV that asks, The X-29 project started at the height of the Cold War and involved a collaboration between NASA, the U.S. Air Force, and DARPA, the Defense Advanced Research Projects Agency. The aircraft company Grumman was tasked with creating this ultimate fighter aircraft. In 1981, DARPA, the R&D wing of the DoD, awarded a fixed-price contract to Grumman. They constructed 2 planes as part of the deal. Grumman would carry out 4 test flights. After successful testing, they'd hand the aircraft over to the U.S. military. Design work commenced in 1984. This was to be the first considerable experimental project of this nature in decades. The plan called for a forward-swept wing plane, which visually stood out. Actually, they hoped these unique characteristics would outperform other modern aircraft. Before this project, the United States prioritized aft-swept wings due to structural limitations that prohibited different wing types. Yet most of the drag benefits were independent of the direction in which the wings pointed. The Germans worked extensively with this type of aircraft. They abandoned the project during the Second World War, in part due to the war's outcome. The primary design challenge Grumman faced lay in how to prevent the wings from twisting due to their direction. If that wasn't challenging enough, it was incumbent upon the team to keep the aircraft light. They needed to develop stiffer wings that required new materials. 2 airplanes built by Grumman modified existing F-5A Freedom Fighter airframes. They also proposed modifications to the General Dynamic F-16 Fighting Falcon, but this idea was shot down in flames. Aeroelastic. The new shape of the X-29 aircraft presented several challenges for American engineers. Among these was the matter of weight. The forward-facing wing designs would be subject to extreme twisting force by headwind. This threatened to break them were they not reinforced. Making them out of metal was out of the question, because the added weight would kill the prospective performance. As a solution, they decided to use a new mix of composite materials, which have since become standard for both commercial and military planes. The aerodynamic lift would twist the wing's leading edge upward, which would lead to structural failure. Anisotropic elastic coupling solved the problem by bending and twisting the carbon fiber composite material without compromising weight. The X-29 introduced a laminate, which could produce coupling between torsion and bending. This resulted in the increased lift. The bending loads would force the wingtips upward. Furthermore, the coupling resisted torsion loads, which would otherwise twist the wing to higher angles of attack. The leading edge would be turned downwards, and therefore solve this problem. By reducing lift, the loads decreased, as well as preventing aeroelastic divergence in the material. Instability. Throughout development, estimates of the proposed aircraft showed 35% instability. In contrast, other planes at the time had a maximum of 5% instability. This new structure produced an unprecedented challenge, which would arguably make the aircraft unflyable. A few test fighter pilots became anxious even before the prototypes were completed. Determining the problem early allowed the team sufficient time to tackle it. Knowing that without a ballast equal in weight to a car on the nose of the plane, they would not be able to stabilize the aircraft, they decided to approach the issue from a novel angle. The design choice, referred to as a 3-surface aircraft, employed 3 longitudinal controls through the canards, forward-swept wings, and aft-straight control surfaces. As a result, the canards and wings reduced drag, both wave and trim. The strakes provided trim wherever the center of gravity was off, and therefore reduced drag. Without a failsafe system, this configuration and the center of gravity behind the aerodynamic center eventually led to an extremely unstable plane. The engineers decided to use forward canards and rear flaps, controlled by a trifecta of redundant computers. Stability was achieved through the flight control system, capable of making 40 corrections a second. The computer system, backed by 3 equally redundant analog computers, rechecked and corrected its own assessments, exponentially reducing the probability of errors. While any of the 3 machines could theoretically assist in allowing the aircraft to fly, redundancy made the system nearly infallible. Each computer sent measurements and made quick assessments, which were weighed against the 2 others. Any malfunctions were immediately detected. At the time, calculations by experts concluded that the 3-computer system was as unlikely to fail as the regular mechanics on a conventionally arranged plane. Still, the unlikely possibility of system failure was terrifying. NASA's Armstrong Flight Research Center historian Christian Gelser stated, quote, "The engineers concluded that if all 3 flight computers had failed together, the airplane would have broken up around the pilot before the pilot had a chance to eject." Furthermore, he claimed the system was absolutely vital. Quote, "It was unflyable, literally, without a digital flight computer on board, which made connections to the flight path 40 times a second." Testing. Finally, the aircraft was completed, and the first X-29 was ready for testing. Its maiden flight took off out of Edwards Air Force Base on December 13, 1984, by Chief Test Pilot at Grumman's, Chuck Sewell. It was the 3rd plane to fly using a forward-swept wing, and the first American aircraft. The technology had been previously implemented on the German planes Junker's Ju-287 in 1944 and the HFB 320 Hansajet in 1964. However, the X-29 achieved what no forward-swept wing plane achieved before: supersonic speed. Pilots who flew the X-29 had nothing but positive things to say of the experimental testbed. Due to its fantastic thrust-to-weight ratio during takeoff and minimal turbulence, pilots agreed that other aircraft paled in comparison. After pilots successfully performed 5 consecutive flights in a single day, the plane was approved. Research flights. Following its maiden flight, the X-29 commenced a 4-month NASA test program. Despite complications and initial challenges regarding the instability of the aircraft, the 3 computer systems proved invaluable. The plane was reliable and, even more critically, deployable. By August 1986, the plane flew multiple times for research missions with durations all over 3 hours. However, the first model of the aircraft had no spin recovery parachute, since all test flights avoided any maneuver, which would take the plane out of a controlled flight. Seeing this drawback, the second model was equipped with a parachute and tested for high angle of attack. It proved to be maneuverable up to 25 degrees, but reaching a maximum angle of 67 degrees. Between 1984 and 1991, the 2 X-29 planes flew 242 times. The Dryden Flight Research Center published an internal report on the new technologies and techniques shown by the X-29. New applications of previous technologies, such as the aeroelastic tailoring, improved the plane's control of structural divergence, aircraft control, and handling. Its success mostly relied on the 3-surface longitudinal control and the advancements made with the second model regarding the high angle of attack. Regardless of the program's future, the X-29 had proved essential data for military aircraft production. Russian clone. Experimental as the X-29 was, the forward-swept wings weren't uncommon. During testing, the American intelligence community discovered Russia had started work on a similar, yet bigger aircraft. On September 25, 1997, the Russian Sukhoi Su-47 took off for its maiden flight. The forward-swept wing experimental fighter was also supersonic and included advanced radar technology and an internal weapons bay. It was in development since 1983, but the project was postponed by the fall of the USSR. The plane was nicknamed Berkut, Russian for Golden Eagle, and had dubiously similar design features to the X-29. Due to the timing and details of the project, NASA historian Gelzer commented, quote, "It's hard not to draw that conclusion, that they saw this and they decided we'd better figure out if it works as well." Yet the Sukhoi plane had some notable differences, which proved it a more impressive fighter. Twice the size of the American model, the Sukhoi was built to be an operational fighter aircraft rather than an experimental test bed. Still, only one plane was ever produced. During development, the supersonic jet demonstrated great agility and maneuverability. This was due to the forward-swept wing, which would inspire a new generation of Russian planes. In 2015, the Russian Design Bureau started testing the SR-10, which was eventually cancelled due to a lack of funding. Plans for the next generation of Russia's jet fighters featured several technologies researched during the Soviet copycat project. The Sukhoi Su-57, intended to replace the Fu-27 and MiG-29, is slated for 2020 production. It's rumored to feature supercruise, stealth technology, and super maneuverability. Supposedly, it will herald the next generation of avionics for both ground and naval defense in Russia. New priorities. The X-29 broke more flight records than any other X-label experimental program. Still, it was scrapped soon after in 1992. The general consensus among aviation historians and enthusiasts is that the cancellation was due to the Department of Defense prioritizing newly researched stealth technologies for aircraft. The forward-swept wing design of the X-29 was incompatible with this new focus. Still, others believe the seemingly superior Russian clone Sukhoi Su-47 intimidated the United States and led the Department of Defense to gravitate toward more ambitious projects. The complete aircraft was exhibited at the Research and Development Gallery within the National Museum of the U.S. Air Force at Wright-Patterson Air Force Base in Ohio. A second X-29 was sent to the Armstrong Flight Research Center at Edwards Air Force Base. The experimental X-29 now serves as a wonder to museum goers.